Okay, I know this is going to sound super technical. We're talking about a programming language update after all. But this is actually a high-stakes story about speed, money, and a single piece of code that completely changed the game on Wall Street. This is how C++11 unlocked a whole new level of speed for high-frequency trading.
So to really get this, you have to understand what's at stake. When you hear a chief architect at a trading firm talk about low latency, he's not talking about seconds. He's not even talking about milliseconds. He's talking about microseconds, 20 of them. That's the total time from when a new piece of market data comes in, that's the tick, to the moment a trade is actually made.
Yeah, let's just put that number up on the screen. 20 millionths of a second. Fortunes, literally fortunes, are made and lost in these tiny, tiny slivers of time. If your competitor is just 1 microsecond faster than you, they see an opportunity and act on it before you even know it exists. So for Wall Street, the race isn't just about being fast, it's about being faster than everybody else all the time.
But, around the early 2000s, Wall Street basically hit a wall, a physical one. Their need for more and more speed was starting to outrun what computer hardware could actually deliver in the old-fashioned way. They had a huge speed problem on their hands.
See, the thing you got to remember is that for decades, software just got faster for free. You just wait a year or two for a new, faster chip to come out, and bam, your programs would magically run quicker. But that whole era was coming to an end. As this report points out, that passive benefit was just gone. To get any faster, software had to completely change how it worked. It had to learn to do things in parallel.
And that's where the hardware folks came up with a totally new game plan. Instead of trying to make a single processor brain run impossibly fast, they just started putting multiple brains or cores onto a single chip. This was the beginning of the multi-core revolution.
Think about it like this. The old way was like having one single, super fast worker trying to build a skyscraper all by himself. I mean, no matter how fast that guy is, there's a limit, right? The new way, the multi-core way, is like having a whole coordinated team of workers building it together. You can get way, way more done, but, and this is a big but, only if they all work together perfectly.
And yep, that's the big catch in all of this. Having a team of processors sounds great, but it creates this massive, massive coordination headache. How do you tell all these different workers what to do without them tripping over each other? This introduced a brand new and really dangerous kind of problem.
Which brings us right to the heart of the problem, the dangers of trying to do everything at once. When you have multiple parts of your program all running at the exact same time, you open the door to some really weird and potentially catastrophic bugs if you don't have some very strict rules.
The most famous one is called a race condition. Just imagine you and a friend are editing the exact same sentence in a Google Doc at the exact same millisecond. What happens? You just get a jumbled, garbled mess. Well, that's a race condition in software. Two parts of the program try to change the same piece of information at once, and the result is just corrupted, unpredictable chaos.
Vance Morrison over at Microsoft put it perfectly. It's all about bad timing between these different threads. And on Wall Street, bad timing doesn't just crash your app. It can literally lose you millions of dollars in an instant.
And then there's the other nightmare scenario, deadlock. The analogy here is just perfect. It's like when two people meet in a narrow hallway. You're waiting for them to move, they're waiting for you to move, and you're both just stuck there forever. In software, this means your entire trading program just freezes solid, completely dead in the water while the market is flying by.
And this is the key, right? For these high-frequency trading firms, a race condition or a deadlock wasn't just some technical glitch. It was a potential financial catastrophe. Corrupted data could trigger disastrous trades. A frozen program meant missing out on millions in opportunities. They absolutely had to find a way to use all these processor cores without unleashing this kind of chaos.
So how did they solve this? Well, this is where the hero of our story finally steps onto the stage, C++11. In 2011, the official standard for the C++ programming language got a major update, and it included this revolutionary new toolkit designed specifically to tame the wild west of parallel programming.
You see, for these firms chasing every last microsecond, C++ was already their language of choice because of its raw speed. But before C++11, trying to use multiple cores meant using all this custom patchwork code that only worked on specific systems. It was messy, it was dangerous. C++11 changed the game by building a standard universal set of rules for managing all this right into the language itself. Suddenly, everyone had the same safe playbook to work from. So what was in this new playbook? Well, it really came down to two main things. First, a much smarter way to manage your team of program threads, and second, a much safer way for those threads to share information without causing a total mess.
All right, let's talk about managing the team. C++11 gave developers these super clear, powerful commands. A command like joining is basically telling the main program, hey, you, wait right here. Don't move on until that other task is completely done. Detaching, on the other hand, is like saying, you know what, go work on that task on your own. I don't need to wait for you. Just get it done in the background. Having this kind of clear control was absolutely revolutionary.
Okay, now for the really clever part, safe data sharing. And for this, C++11 introduced an incredible tool called a mutex, which is short for mutual exclusion. The absolute best way to think about this is like a talking stick in a meeting, right? Only the person holding the stick is allowed to talk. A mutex is a digital talking stick. A thread has to grab this lock before it can touch a piece of shared data. And while it's holding it, no other thread can get in there and mess things up. It's a simple idea, but it completely eliminates race conditions.
So what happened next? Well, with this powerful new toolkit in hand, developers on Wall Street could finally let those multi-core processors off the leash. And the results? Well, they were just staggering.
And look, the proof is right here in the numbers. This chart says it all. This shows what happened when a task was rewritten using these new C++11 tools. The time to get it done went from over 17 seconds all the way down to under 3 seconds.
I mean, let's just pause on that. A 6-time speed up. In the world of high-frequency trading, that's not an improvement. That is a whole new dimension. That's the kind of performance leap that can literally make or break a trading firm. It was a total game changer.
So in the end, C++11 wasn't just some boring software update. It was a complete paradigm shift. It was the key that finally let the software catch up to the hardware, unlocking a level of power that people could only dream of before.
And that really leaves us with this big, fascinating question for today and for the future. C++11 was the answer for its time, but now processors have dozens, sometimes hundreds of cores. As that number just keeps going up and up, what are the new ideas, the new tools we're going to need to make sure all that incredible power doesn't just go to waste?